Hello everyone. Now I'd like to discuss the topic limiting reagent, excess reagent, theoretical yield, and percent yield. For a chemical reaction, and as indicated here by a skeleton equation, hydrogen gas, remember the formula for hydrogen gas, molecule is H2 mixed with oxygen gas, and is O2 with a little bit of spark, you produce water, it's H2O plus release heat. As you can quickly sense now, and you do the atom inventory, and you can realize this is not a balanced. According to the law of conservation of mass and all the chemical equations, that is properly representing the any chemical change has to be balanced. The only number you can change, anyone can change in trying to balance a skeleton equation are the coefficients. Quickly, you can go through the process, and we'll have 2, 1, 2. You have 2, 1, 2 coefficients. Now you can see there are 4 hydrogens and 2 oxygens on each end, the reactant end and the product end. So hence this equation is balanced. For any balanced chemical equation, what would be the meaning of it? And this is where the stoichiometry is based on. Stoichiometry is based on. It means 2 moles of hydrogen is equivalent to 1 mole of oxygen. It's equivalent to 2 moles of water. As you understand, the molar mass for hydrogen is 2 grams per mole. Molar mass for oxygen is 32 grams per mole. Molar mass for water, H2O, is 18 grams per mole. So hence you can actually rewrite it in this case is 4 grams of hydrogen gas is equivalent to 32 grams of oxygen gas is equivalent to 36 grams of water. Simply translate the moles into grams. And this is what we call the stoichiometric stoichiometrically matched. So let's take a look at the equation again, and now we have a real case. If we're mixing 2.0 grams of hydrogen gas with 12.0 grams of oxygen gas, how many grams of water will be produced? You realize this is not stoichiometrically matched. So which reagent will run off first? And that one will be what we call the limiting reagent. Because when that reagent runs out, the whole reaction stops. Which one will have leftover? And means what? And that's going to be in excess. It's going to be called excess reagent. So how do you do that? And there's a process. This was the main thing we're going to discuss today. Is this step number 1. Pick any reagent. Calculate how much is needed for the stoichiometric amount of the other reagent. So then let's see what for this particular one you have balanced the chemical equation. You started with 2.0 grams of hydrogen, and you want to calculate how many grams of oxygen gas that will match 2.0 grams of hydrogen, and make sure they are completely reacted. For doing that, this is a typical stoichiometry calculation. You're going to looking at this familiar monkey bar. You started with 2.0 grams of hydrogen. What you want to calculate is the grams of oxygen. So grams of hydrogen goes down the bottom because it has to be cancelled, and going up will be the mole of hydrogen. And now you realize you have to switch the content within the parentheses. You switch between moles. Now you cancel the mole of hydrogen. You switch it over to mole of oxygen. Once more, mole of oxygen gas and grams of oxygen gas. Now you're going to fill in all the numbers for the 3 conversion factors involved in this calculation. It's very simply 1 mole of hydrogen gas is equivalent to 2 grams of hydrogen gas. And now it's 2 moles of hydrogen gas is equivalent to 1 mole of oxygen gas. Simply this is a 2-to-1 ratio based on balanced chemical equation. 1 mole of oxygen gas is equal to the 32 grams of oxygen gas. So you can double check on that. Grams of hydrogen, H2 cancelled, more of H2 cancelled, more of O2 cancelled. You got what needed to be calculated gram of oxygen gas, just O2. And the calculated value will be 16.0 grams. 16.0 grams of oxygen gas. So step number 2, now you calculate the stoichiometric amount. Now you compare what is available. In this case is we took the 2.0 grams of hydrogen gas, we calculated it needed 16.0 grams of oxygen to complete the reaction. But what is available is 12.0 gram. So logically, oxygen, the O2 will run out first, and it's a limiting reagent. And H2 will have leftover. That will be the excess reagent. It's kind of counterintuitive because initially you have 12.0 grams of oxygen gas to start with, only have 2.0 grams of hydrogen. Don't be fooled by that. You have to go through the process, and the reason for that discrepancy is oxygen gas is 32 grams per mole, hydrogen gas is only 2 grams per mole. And also involved in here is the mole ratios based on the coefficients in the balanced chemical equations. See, alternatively, you can also choose the other reagent, choose the oxygen, then calculate how many grams of hydrogen gas that is needed. Same step 1, get a balanced chemical equation, and now you have starting with 12.0 grams of oxygen. You want to calculate how many grams of hydrogen that will be needed to completely react with this amount, this many grams, 12.0 grams of oxygen gas. You do the same monkey bar, grams of oxygen, mole of oxygen, O2, mole of hydrogen H2, and mole of hydrogen H2, 2 grams of hydrogen H2. So you have 1 mole O2, 32 grams of O2, 1 mole O2, 2 moles of H2, 1 mole of H2, 2 grams of H2. Double check, got what you want, the unit wise, and calculate based on those numbers. You're going to have 1.5 grams of hydrogen gas that is needed to completely react with 12.0 grams of oxygen gas. Step number 2, compare what's calculated and what's available. This is 12.0 grams of O2 needed, 1.5 grams of H2 to complete the reaction. What is available is 2.0 grams of H2. You have more than enough. Once again, you draw the same conclusion. Oxygen gas, O2, will run out first. It's a limiting reagent, and H2 will have leftover. That will be the excess reagent. So after we figuring out what is the limiting reagent, what is the excess reagent, there's an additional question we can ask. How much of excess reagent is left after the reaction has stopped? So you know the amount of the oxygen gas needed is 1.5 grams to completely react with 12.0 gram of oxygen gas. And now available is 2.0 grams of hydrogen, so how do you calculate how many grams is going to be left? It's also called the amount in excess is. You just simply take 2.0 grams of hydrogen, and that is what is available. You subtract what stoichiometric amount that is needed to complete the reaction. In this case is 1.5 grams, and you're going to get 0.5 grams of hydrogen. This is amount in excess. Here comes another question. What is the maximum amount of water in grams that can possibly be produced in this particular reaction? And this is the maximum amount. And it's also have another term. It's called the theoretical yield. Theoretical yield means the maximum amount that is possible. So now you start with the amount of two reagents, 2.0 grams of hydrogen and 12.0 grams of oxygen gas. Which one you should pick for this stoichiometric calculation? And the only logical choice will be taking the amount for the limiting reagent, since the limiting reagent will run out first, and as soon as the limiting reagent runs out, the reaction stops. You cannot possibly use the amount for the excess reagent to calculate the maximum amount, the product that will be formed. So we have this one. We have this 2.0 grams of hydrogen and 12.0 grams of oxygen. As the previous discussion has indicated, the 12.0 gram of oxygen gas, it is the limiting reagent. So we'll have to take the amount for the oxygen gas to calculate the grams, the amount of the water in grams that will be produced. Very similar stoichiometric calculation, grams of oxygen to the bottom, mole of oxygen to the top, mole of oxygen gas to the mole of water, and then mole of water to grams of water. 1 mole of oxygen gas is equivalent to 32 grams of oxygen gas. 1 mole of oxygen and is equivalent to 2 moles of water based on the balanced chemical equation. 1 mole of water, 18 grams of water. Check on the unit, and they all line out. The calculated value for theoretical yield for this particular reaction is 13.5 grams. 13.5 grams, which means with 12.0 gram oxygen gas, the limiting reagent, the maximum amount of water that can be produced is 13.5 grams. Things get complicated in real life. So in most chemical reactions, the reaction doesn't go to 100%. And so the product yield, the actual yield, is less than the maximum amount. So then I'll introduce you the other parameter. It's called percent yield. Percent yield is calculated as you're taking the actual yield from the reaction, that's measured value, and you just divide that by the theoretical yield, that's calculated value, multiply that by 100%. Multiply that by 100%. For the previously discussed chemical reaction of hydrogen gas and oxygen gas, if the actual amount produced, the water produced, is 10.8 gram, what is the percent yield of the reaction? So as we said, percent yield is equal to the actual yield in grams divided by theoretical yield in grams times 100%. And see, the actual yield is 10.8 grams as given above. And from the previous discussion, the theoretical yield for this particular reaction is 13.5 grams. And you carry out the calculation, it turns out to be 80.0%, which means the reaction went to 80.0% completion. To summarize this process, step number 1, got to get the balanced chemical equations. That's critically important. And step number 2, choose any one of the reagent. any one of the reagents. Calculate the stoichiometric amount of the other reagent needed to complete the reaction. And then you compare. You compare the calculated value with what is available to determine which one is the limiting reagent, which one is the access reagent. Use logic to process this. And also you can calculate the amount of the leftover from the access reagent accordingly. So the step number 4, you use the amount for the limiting reagent, calculate the theoretical yield for each product. You have to use the limiting reagent. The last one, you can calculate percent yield based on the actual yield and the theoretical yield. This is it. Thank you very much for your attention.